Hello, ladies and gentlemen. If you can hear me, please raise your hand. If you're trying to ignore me, then put your hand down. Welcome to our session. This is how to use your ELB to enhance your security posture at scale. My name is James Wenzel. I'm a Principal Solutions Architect, and what I do is I help you. I'm sure all of you are familiar with architects, yes? Good, good. I help you out with making recommendations, doing presentations like this, but I'm also joined by a special guest, Priya.
Hello everyone, I am Priya Patel and I am the product manager for the Elastic Load Balancing team. What I do is hear your voice, meaning the customer voice, and bring the features to launch.
Okay, so let's get into what we're going to be talking about today. Our agenda is to talk about ALB, NLB, and Gateway Load Balancer. What we're going to talk about and discuss is the security that they can help you provide to your workloads, as well as how we secure those down for you that you can inherit for your workloads. And then at the end, we're going to give you a couple of links that you can use to actually audit these in any type of auditing process that you have with APIs. You will get a copy of this slide deck so you can go ahead and use that as you need. Okay. So let's talk a little bit about load balancing without ELB. ELB, as you know, or Elastic Load Balancing, is a managed service. So a couple of things that you need to take care of yourself is that you need to do routine security patching. You need to kind of over provision because this won't scale automatically. And what that means is you have to pick an EC2 instance that is large enough to handle your peak traffic, which is more or less an anti-pattern of what we want you to do of only use what you need. The other thing you need to do is you need to make sure that your configurations are actually going to be in sync. With ALB, ELBs, our configuration is obviously kept in sync for you because we handle all of the scaling, which is the next topic I want to talk about. When you look at the scaling of an EC2 instance, sometimes you'll have to do maybe a disruptive service, like say for instance 2 isn't good enough, you need to actually add 3 or 4. So what you would have to do then is actually change your configuration, make sure your sync is all set up, all of that fun stuff. Also, you need to make sure that you handle your patching whatever software you're using, or patching the actual EC2 instances when patches come out. When we are using ELBs, we do all of that for you. And then lastly, and sometimes most importantly, these load balancers are supposed to load balance something, right? Traffic going to your targets. With ELBs, you have the advantage of auto scaling, so that you can set up measures of, say, CPU or memory or whatever it is that you know your application will reach a threshold at, to go ahead and automatically add more Amazon Machine Images or AMIs to your back end so it can scale out. And also importantly, to scale down when you're no longer actually consuming all of that traffic. So the other thing I want to mention too is that inherent security. Now, how many of you are familiar with the shared security model? Have you heard about it? Yeah, we've got hands. That's the deal where we handle the security of the cloud and you handle the security in the cloud. So one of the things that ALBs, ELBs, and gateway load balancers enjoy is they're all inside of a VPC. A VPC is software-defined networking. Basically, pieces of software combined together, scaled throughout all of our AZs to actually help handle your traffic. But the cool bit about that is that our traffic is basically monitored and labeled at multiple levels. So you have your physical layer where we actually run the machines that your AMIs and all of these VPCs run on top of. That has an ID. Then you run your stuff inside of a VPC. Now remember, a VPC is something where you cordon off traffic, where you have the control of who can come in and who can go. So it's your private space. We have IDs that are unique for every customer, for every VPC, that we label on that encapsulation. So why do we add all of these specific IDs to all of these pieces? Because if we detect something is off, if an ID doesn't match between communications from one side to the other of the VPC, or from one side to the other of the Amazon platform, we're not going to allow that communication to speak. So it's very, very important to note that ALBs, NLBs, and gateway load balancers operate within this space and inherit this type of security, so there's really no crosstalk. If you're bringing your own device, you're kind of using that EC2 instance and you're lifting yourself off of that platform and you're relying on the software that you're using or configuring on EC2. So I'm going to hand it over to Priya and she's going to talk a little bit more about ELB with encryption.
Jamie has just talked about how ELB is built with security in mind. let me walk you through how ELB is built with encryption in mind. The way we think about security is three ways, meaning the traffic which is incoming into your ELB, the traffic which resides at your ELB, and the traffic which is outflowing from your ELB. What I'll also show you is that how we secure your data while you're dealing with ELBs. In this slide, I'll also walk you through how do we manage security when we deal with the other services in AWS, meaning the ACM and the KMS, which is the AWS Certificate Manager and the Key Management Store. So let's walk through this. You have your normal traffic flowing from your clients. Okay, so from your clients, it's flowing through your ALB or NLB, and then it's flowing to your end targets. What is happening right here is that customer, they can either store their certificate in the ACM, they can import their certificate into the ACM, or they can create a new certificate into the ACM. The ACM at this point, what it would do is that it would call over to the KMS, says that, hey KMS, create a new AWS managed key in order to encrypt the private key, which is there at the ACM. At the same time, what it would do is to give a grant to your ELB to access the KMS key. Now come over to the ELB. What the ELB will do is that get that encrypted private key from the ACM. It calls the decrypt KMS API, decrypts this private key. Till this point, whatever actions are happening, it is happening at the ALB control plane level, right? After this, whatever TLS negotiations are happening, that all can be handled by you customers at the ALB data plane level. And this is just the tip of the iceberg. There are a lot more features which Jamie and I will be walking you through, and these all features are built keeping security at the core of the mind. Let's talk a little bit about the ELB family. As you all know, ELB, it's a managed service in AWS. It's highly scalable, it's highly available, it's resilient, and it's built with built-in monitoring and management. Also, it's very integrated across the other AWS services. Let me walk you through how we started off with the ELBs. We started off with the classic load balancers, which is a layer 4 to 7 load balancing solution. And it was built for the EC2 Classic environment. Let me drop a note. While we are not actively deprecating the classic load balancers, we are also not building more features over the classic load balancers, and we want our customers to actively use our newer offerings, which I'll talk about, which is the application load balancer, network load balancer, and the gateway load balancer. Let's dive a little bit into these three load balancers. So the application load balancer out here, this is for your layer 7 load balancing. It is for request level balancing. It supports HTTP, HTTPS, and gRPC. It supports advanced rule-based routing. Works great for your front-end stores, APIs, REST. You can use the application load balancer. Let's talk a little bit about the network load balancer. This is your layer 4 load balancing, works at the connection level. It supports your TCP, TLS, and UDP traffic, and it's built for scale, low latency, and ultra high performance. So all the gaming folks out here who care about the speed, network load balancer is your ideal option to go after. And the latest offering to our portfolio is the gateway load balancer. A gateway load balancer is a transparent network gateway and a load balancer. It has a single entry and exit point for all your IP traffic, and it improves your appliance availability. Again, it's highly elastic and scalable, and it reduces costs. Let's talk a little bit about the benefits of the ELB. ELB, as you can see, it's highly scalable. We are elastic. It scales through auto scaling. It's highly available, so availability is a tenet we focus on. We want to make sure that your applications are highly available when you're using ELB. It is also very cost effective. It's much easier for you to use an ELB than to try and build it yourself, playing around with the EC2. It's also highly integrated. We're integrated with approximately more than maybe 14 other AWS services, including auto scaling for scaling, Route 53, we have Cognito, we have WAF, and a lot others which are integrated through it. And lastly, but not the least, we are highly secure. We use end-to-end encryption. We ensure that we are using the latest SSL and the TLS ciphers and protocols to ensure that your traffic is secure. We do the SSL for you so that you can concentrate on making these amazing applications for your customer. I'll talk a little bit about the application load balancer. Application load balancer, as you see here, the traffic is coming in from your source, and the source can be either the internet or it can be your internal workloads. It's going through your application load balancer, which is again operating at layer 7, works for your request level load balancing. And once the traffic is in at the application load balancer, it moves into your targets. And the targets, typical targets out here, it can be the Amazon EC2 instances, it can be your AWS Lambda, it can be AWS Fargate, EKS, ECS, IP address, any of these out here. We also support a lot of, so AWS, at the same time, I do want to highlight that ALB does focus on security. We make sure that we are using the latest SSL and TLS so that your sessions are very secure while you're using ALB for your workloads. We support a number of features. A few of them would be, we have support for sticky sessions, and again, like these occurs both at the load balancer level and the application level. We have support for content-based routing. We support multiple load balancing algorithms. There is support for HTTP, HTTPS, there is gRPC support. We support WebSockets. And I know like Jamie has a lot to say about health checks. Jamie, if you want to.
Sure. How many of you have actually configured health checks on ELB? Right? Now, how many of you, be honest, have configured like just TCP and it pings back? Good. Well, got one. But the thing that you want to make sure of is that that may let you know that your target is responding on TCP, but the thing that you want to make sure of is that you set something like a status page, right, within your application that holistically looks at everything that's running, and then set your health checks to actually check that status page. If it doesn't see that string, then have it fail. The other thing that really helps out with this too is, let's say you have an event, heaven forbid, you want to be able to understand what went wrong. So if that string changes, you can have it say something like, this part of the application failed, this container went down, or this piece is no longer running. So that way you can actually recover that much quicker. Because we do see a lot of folks that are actually in very large companies, surprising, not really, well, it is surprising, that they'll set something like this up where, hey, if it pings, it's good. And we all know the application world is a little bit more complex than that.
And just the last point, we are also highly integrated. You have integrations with WAF, we have integrations with, which is the web application firewall. There is AWS Certificate Manager, Cognito, to name a few. Let me walk you through the logical overview of ALB. So it is a single tenant system. It's built for scale and it's highly elastic. The intent out here is to make you given the minimum input for the maximum impact which you want. Looking at this, we have the listeners, and instead of configuring one single port to your backend, you can configure different routing rules to your backend targets. And the targets, again, can be either Lambda, EKS, ECS.
So I'm going to talk a little bit about some of the features. Now, one of the things that I would like to note is some features are shared between ALB, NLB, and Gateway Load Balancer, and some of them are a little bit different. We've mentioned a little bit about TLS, and of course Priya loves TLS, and she'll talk a little bit more about that later. But the offloading is really, really important, right? I've actually had it before in the past where I've actually said, you know what, I don't need to have offloading. I'll just do it on my very large machine. And then it brought it to its knees. So it actually does save you on compute power in that regard. The other thing too that we have is integration with authentication or authentication Passover. So it'll actually handle by proxy authentication for you, so you don't have to necessarily build those things or run them in the app. The other thing we also support on ALB is security groups. So not only can you block things at the listener level, I'm only going to listen to this particular port to go to my particular service, but you can also block things at the IP level, just strengthening another layer of security on top of that. I'd also like to take a note that, remember when I was mentioning earlier about the VPC and how we build with security? What also comes with that is some forms of compliance. PCI, HIPAA, all of those things, right? Shared security model, you need to make sure that your applications also meet up with that to the fact of what we have here. Now, one of the questions we often get is, well, what kind of attestations can I get or where can I find them? there's a site called Artifact. Some of you may be familiar with it. You can grab it through the console, and you can go and search and find out what attestations you have for PCI, SOC 2, HIPAA, all of those fun things. And then you can grab that and give it to your auditor and say, hey, this is already handled for us on the infrastructure level, and then prove to them out only on the application level. So it kind of reduces that stress for auditing. One other thing that I'm also pretty passionate about is tagging. How many of you use tagging? How many of you use human tagging? So one of the things that's important to note is that when you do tagging, make sure that when you're looking at it, you know what it's for, right? It's okay if it's programmatic, but then if you have to look that up later on, or if your application doesn't really take advantage of it, it may make things a little bit more difficult when you have a lot of resources, especially when you're building out. This also works with IAM, where you can actually grant resources or grant permissions to these resources as well. Who can change this, what changes can be made, all of that. And as well as it works with AWS Config. AWS Config is a great tool. It's also another managed service that we integrate with ALB and NLB, as well as Gateway Load Balancer. So if you want to find out what security groups are actually associated to your ALB, AWS Config will help you with that. If you want to find out what changes or what's different in the configurations of your ALB, you can go back to config and look at the timeline. So it's something that's really good to look at and give you to your arsenal for security and compliance. You can even set up rule sets in config to say, hey, this is not configured the way it's supposed to be. So please send out a notification, complain, all of that. The other thing too that we also do is we of course do logging, so you can actually look at the logs of the ALB and see what kind of access you have or what's going on. But we also integrate with CloudTrail. CloudTrail is that tool that will tell you who accessed what in AWS in terms of the actual constructs, by what IP and when. So if something happens, a configuration mistake happens, you can narrow it down to who, when, and where. The other thing we do is CloudWatch. I'm sure a lot of you are familiar with CloudWatch. The most powerful thing is to be able to set alerts. And you can say things like, well, if this particular condition happens, you can, of course, send an SMS or a notification. But what else you can do is you can actually add a Lambda and say, okay, if this happens, do something about it. You can be more proactive. That's a very, very powerful thing. Now, the one thing that's unique, as Priya had mentioned about ALB, is that it operates at layer 7. One of the things that we have, and I'll get into this a little bit later, is that the NLB can actually operate as a target now. Our ALB can operate as a target of NLB, sorry. That's very powerful because before, when you wanted to take advantage of something like private link or a static IP address, like if you're going to do any type of allow listing, you had to have like a Lambda kind of running off on the side, and then it would basically grab all of the IP addresses from NLB or from ALB and stuff it into NLB as targets. And we'll discuss a little bit about the IP addressing of ALB as well. Also, we do desync mitigation, which we're going to be talking about. You can also preserve your source IP address so that your clients or your application can know what IP addresses your clients are coming on. So we have those features. Is there anything you want to talk about, Priya?
We can go ahead.
We can go to the next one? All right, so we're going to go to the next one. She's telling me to move on. So here we have an example of ALB. ALB is operating just as we want it. Let's say this is a front end, this is a storefront, something that will require layer 7 traffic to come in. And it's distributing the traffic just fine between a pair of EC2 servers. We're actually, we have two public subnets. Those public subnets are, of course, because of the proxy nature, switched over to the external IP addresses provided by the ALB. We can do cool things like add Lambda as well as our EC2 systems. We can even go further and say we want to run just a microservices architecture with our ALB, right? It has a very large myriad of target availability, target features. And let's say we want to run all three. Now, one thing I wanted to point out that you may have noticed when we went through each slide is as the ALB is scaling out, it's consuming more IP addresses. Now, Priya promised that we were going to be talking a little bit about scaling, and I want to make sure that you understand that if you're using ALB and you're going to provision CIDR blocks to your VPCs, please make sure you give enough of those IP addresses out for your public subnet so that your ALB can scale with your traffic. There are some folks who have a mindset of like, I only want to have 4 IPs out in the public subnet. Well, then you can only scale to a certain degree. So if you have a highly performant network, use a larger block so that you can actually scale out and take advantage of all of those.
Okay, let me talk a little bit about the desync mitigation protection. This feature is available both for your ALBs and CLBs. And what it does is that it will protect your traffic against a class of security attacks, which is called the request smuggling. This occurs when you have a chain of proxies that may handle requests that are non-compliant to your RFC 7230 differently. And you don't need to do anything. We have it enabled for you in the default mode, in the defensive mode, sorry. The load balancer classifies each request based on the threat level, allows a safe request to go through, and then mitigates risk as specified by the mitigation mode that you specify. So if you look out here, you have the normal client, the request, the TCP packets going in, which are green to your targets, and here is a disruptive user which is trying to prepend data to client requests. And this happens when the desync mitigation mode is not enabled. It would let you pass this traffic and usurp your normal session.
So let's talk a little bit about WAF. I mentioned that we're going to dive a little bit deeper into this. WAF is a great tool, web application firewall, to actually set up the rules and conditions of how your users or anyone out, say, on the internet can interact with your application. You can set up these rules to do things that are a little bit more than just your standard ACLs. You can actually use it to monitor and check to see if those bots, those pesky crawlers out there, are actually eating up too much bandwidth that your users are supposed to be using. I mean, your applications are built for humans, right? So the other thing too you could do is you could use it for visibility. So you can set up rules and counters and find out how many people from what particular location is going through your ALB and how many are hitting your particular pieces within your application and your targets. But one thing I want to also caution out there is that if for all those DevOps folks and those that are actually in control of the WAF and changing the rules, as your applications change, please have regular meetings or sit down or bring your devs to the table so that when they actually change the application and that application gets propagated to production, WAF doesn't start blocking and then you don't have the ability to show off to your customers all the new features that you have. Now remember I talked about authentication a little while back. We're going to talk a bit more, and Priya is going to do a little bit of a deeper dive on how it works, but just to kind of go over the top of it, what you can do is you can offload your authentication. So what that means is that you can basically do single sign-on, like a secure experience, all through ALB. You could basically use ALB as a, basically a relying party for between your application and your customers, and basically supports code authorization grant flows as well as OIDC support. The other thing we integrate with is Amazon Cognito. Cognito has the ability to create its own user pools if you want to use it just within the AWS service to do something more simple, but Cognito also gives you that gateway or that key to allow you to do things like SAML, integrate with Microsoft AD, you could also integrate with any OIDC as mentioned before, or even LDAP. The other cool thing that you can do is for those of you who use, let's say Amazon, I'm going to say that first, or say Gmail or any of those types of IDPs, Facebook, for your authentication methods or mechanisms, you could actually use Cognito to actually go ahead and connect those pieces up as well. Now this is all easily configured through the listener rules, so you don't have to go through all those configuration files, talk to your customers constantly and try to get all that in sync. You can actually do it pretty easily within the ALB itself. Now Priya is going to walk you through how this actually works. And there's a lot of steps, so please pay attention.
Let me walk you through the authentication workflow in an ALB. And the first step is that the user sends the HTTP request to your website, which is hosted behind the auth-enabled ALB. Now the ALB will check for the auth session cookie, and it redirects the user to IDP if it is missing. The third is after authenticating with IDP, user is redirected back to the ALB with the authorization code. Next, ALB authenticates the code and sends to token endpoint. Fifth, token endpoint exchanges code for ID token, access token. Then ALB sends access token to the user info endpoint. Next, the user info endpoint exchanges access token for user claims. ALB would redirect the user with the AWS ELB auth session cookie to the original URI. Next, ALB validates cookies and forwards user info to the targets in the Amazon. The header is written out here, this header. And second last is target sends the response back to the ALB. And finally, ALB sends the final response to the user. So this is how the entire auth workflow would work in an application load balancer.
So now this slide contains a little bit of spoilers because the next topic is going to be NLB, but I wanted to come back to ALB being a natural target of NLB. Now what this slide encompasses is all the benefits of both worlds. We went over ALB and how it actually integrates with ACM. NLB also does the same. ALB has a feature that NLB doesn't have where it integrates with WAF and it does your authentication offloading. NLB, as I mentioned, has a static IP address that doesn't change, and it also has the ability to do Private Link, which is a unidirectional stateful flow service that you can offer to customers or offer to other parts of your organization, and you don't have to worry if you check out the VPC CIDRs on the two VPCs in the bottom about IP overlap, and it's unidirectional. So you can take those two pieces and get best of both worlds, plus security best of both worlds within these applications. So we're going to dive in a little bit more with the network load balancer.
I can talk about the NLB. Again, as we've already discussed a little bit, this operates at your layer 4. The source out here would be either your internet, you have your internal workloads, or also the Amazon VPC interface endpoints. The traffic from your source would move into your NLB, which is operating at your layer 4, and it would move into your backend targets. The targets out here would be in the form of either Amazon EC2, it can be AWS Fargate, it can be Amazon EKS, Amazon ECS, the IP address, and Jamie's already mentioned how we've introduced ALB as a target of NLB. NLB operates at fast speeds, so there is ultra low latencies. This will come into picture when timing and scaling is of matter to you. So all the gaming customers or even the FinServ customers can take leverage of NLB. At the same time, we support a number of other features, like there is zonal isolation, there is long-lived flows, there is also support for sticky sessions, there is IPv6 front end, there's support, but this operates at layer 4, so there is support for TCP, UDP flows. And again, like there's support for static IP, there is external elastic IP. And I know Jamie had a few thoughts about NLBs, yeah.
One of the things about NLB, when you use it, you'll notice that you'll get an internal IP address, again, that's static. One of the cool things that you can do is add an external IP address or EIP to that. The EIP will give it its ability to kind of be in existence out on the internet. The other cool thing is if you need to do any adds, moves, or changes, destroy or move your NLB for whatever reason, that EIP could be simply disassociated and reassociated to the new NLB. So that kind of synergy works pretty well on a networking level, as well as allowing you to keep uptime. For this, you would just take your EIP, and you can go ahead and allow list that with all of your customers. Say, hey, this is the IP address, it's never going to change. You can actually promise them that. I don't know how many times you guys have run into that where I've had to go back and say, I promise this is the last time, you're going to have to change your IP address in your firewalls. Well, with EIP and NLB's static ability, you can actually keep that promise. And again, Private Link, we'll be talking about that one in a little bit. That is an excellent way for IP overlap. It is another way to give your customers, if you want to offer them a solution of native integration to your products, to let them know that it's unidirectional, stateful, you can't reach in, all of that fun stuff.
Another small benefit I want to highlight about NLBs is that it is optimized to handle sudden and volatile traffic patterns while using a single static IP address per availability zone. This is definitely something which you want to leverage about. And also we have the integration, so we see the integration with the AWS Certificate Manager, which you can leverage. Let me walk you through the logical overview of an NLB. It's pretty simple. You're out here, you have NLB, you have your listeners, and again it is for your TCP or the UDP flows, and it would go into your different backend target groups. The target groups can be in the form of auto scaling for EC2. You have support for hybrid IPs, meaning it can either be on-prem workload or it can be your application workload. The last is support for containers through the ECS target group.
So handling some of the features, you see some similarities with TLS. Again, NLB is great for TLS offloading, keeping that extra workhorse or that extra power needed to do your termination off of your backend servers and backend targets, so you can keep them as nimble as possible. We have ALPN, which will be discussed a little bit more by Priya. We still have that whole tagging thing. Please make sure that all your tags are set up well and you can manipulate. But you notice that those are very similar. The one thing I want to kind of call out, even after the config and all that stuff, is layer 4. As Priya mentioned, this operates at layer 4. It is meant to be fast. It is meant to get those packets from your customer to your backend as quickly as possible. It has the private link integration, and of course, it has the same ability to preserve the IP address in case your clients need to know where things are coming from. So talking about Private Link, we're going to break this down a bit. Private Link, some of you have actually probably been using Private Link with AWS services. Like for instance, if you have Lambda, or if you've actually used DynamoDB and you wanted to use it in a private sense, you get that endpoint that goes inside your VPC that you can naturally integrate with or naturally communicate with like it's a local IP. But you can also do this yourself, and you can offer it to either other parts of your organization or even completely different customers. Remember I mentioned that this helps with the whole fact of IP overlap. So if you have a bunch of customers that you want to offer a service to in a secure manner, you don't need to worry about what their IP addresses are. You can offer them the Private Link endpoint, which you can see here on the right-hand side. That Private Link endpoint will require a security group. So you get that IP level security actually there as well, that stateful firewall, if you will. All the flows, you'll see the arrows are pointing in one direction, that unidirectional stateful flow. That unidirectional stateful flow is very powerful because you don't need to worry about putting firewalls on both ends. The traffic will only flow through whatever the NLB's listener is allowing to go through. The cool bit too about Private Link is those local IP addresses are routable. Those are ENIs, Elastic Network Interfaces. So if you have customers or if your organization wants to get access to anything that this is being offered to, you can even go through a VPN or you can go through Direct Connect and access it on site. So that routable IP address takes a local IP address from the consumer side, the right-hand side. On the left-hand side, of course, our NLB is there, and it is actually offering that service. So if we're going to go a little bit more into the features, I already mentioned that it all happens pretty much behind the scenes. It doesn't worry about IP overflow, but you don't need an IGW either. The IGW, the Internet Gateway, which gives access to the internet, you don't require that because this is handling and happening on the AWS backbone. AWS backbone is something that we control entirely within regions and across the globe. We don't use anybody else for our backbone. It's all our own fiber. We control it ourselves, and we also monitor it, and we understand when it's coming towards capacity. We always leave a large space so that you don't have to worry about your packets slowing down. Because of the fact that you don't have to worry about firewalls, you can also reduce your cost. You don't need, you just need to do the service, and the service takes care of that for you. And as I mentioned before, it's unidirectional, it's stateful, and you can place your endpoints wherever you need them to be. Some people like to centralize, but when you do centralize your endpoints, please keep in mind that you're going to be dragging traffic through transit gateways or different thresholds, so you'll go as fast as your slowest link. But if you actually put it as close as possible to whatever's consuming it, you can consume up from 10 to 40 gigs of traffic through that endpoint. So it's pretty nimble. It's actually a really good service. So if you are not familiar with Private Link and you're not using Private Link, I strongly encourage you to look it up. But as part of Private Link, NLB is the back end piece. And the simple way that you can actually offer that out is that on the NLB, you can offer something through the Private Link service, and then you can have your customers accept that service, and then when they accept that service, another request comes back to you to where you say, okay, turn it on. So that's mutually authenticated. So I don't want you to think that when you're offering something through Private Link, anybody in the world can just connect to it if they know the secret string or URL. Now, let's say if you have to do this internally, you do have the option of turning that authentication, that mutual initiated authentication off, so that you can automate this process as well. So if you trust your users and you trust your internal organization, automate it. If you're sending it out to customers, please make sure you set up forms of authentication.
Let me talk a little bit about the TLS 1.3 support. So we do support TLS 1.3 now, and you can enable it through your NLB TLS listener. It makes it more faster and more secure as compared to your TLS 1.2. And again, hammering on the point that NLB, if you care for your performance, if you want faster performance, this is something which you can totally leverage on. A call out for all the gaming companies, the FinServ customers, this might be something which you want to loop onto. Let me also highlight a little bit about the application layer protocol negotiation, which is the ALPN. What is an ALPN? So ALPN, it's a TLS extension that includes protocol negotiation within the exchange of hello messages. And the benefit which an ALPN would give you is that it's able to negotiate which protocol should be handled over a secure connection that is efficient, and it avoids that extra round trip, again making it a little bit faster as compared to the normal round trip time.
So now we're going to talk about the last application, or the last ELB, which is the Gateway Load Balancer. The Gateway Load Balancer is something that can be handled at layer 3 and at layer 4. Layer 3 gateway, layer 4 load balancer, sorry. So this slide is a little bit more confusing, and I want to just kind of break it down. How many of you have actually used firewalls in your workloads? Okay, how many of you are using Gateway Load Balancer? Okay, so one or two. This is good. When you use firewalls on your back end, one of the struggles that a lot of our partners, which we love, is that how do you make these firewalls HA? How do you make them scale? Right? How do they transfer state back and forth? How do we give what we like to call a native experience, native cloud experience to our users? So what we do is we came up with the Gateway Load Balancer that allows those firewalls to actually auto scale. Our source and our destination could be internet or internal workloads, depending on how you want to actually inspect that traffic flow. So if we're starting from our left, you'll have an endpoint out there that your internet or your internal workloads will send traffic through, typically through a mechanism such as ingress routing, where you're capturing those packets and sending it through the Gateway Load Balancer. It then goes up and encapsulates those IP addresses entirely so that we don't change anything with the source IP, header, payload, any of that stuff. It goes to the firewall just as if it would have just gone right through your firewall in itself. It understands the flows, so if it goes to one particular firewall, it'll continue sending that flow to that firewall, so nothing will get dropped as something gets passed around. As your needs grow, when you're sending more and more traffic, your website is doing awesome, your internal workloads are churning because of some month end, it'll actually help you auto scale and add more firewalls to your fleet. And when you're not using them, it'll actually reduce those firewalls to your fleet. Now, it's important to note that we have something called Geneve, which is doing the encapsulation, so when you're picking your firewalls, make sure they support that. The reason why I bring up Geneve is because at the Gateway Load Balancer level, to the targets, it actually will handle that type of encryption. The other thing too is those Gateway Load Balancer endpoints are able to be distributed just like Private Link. So you can put your endpoints where you need to have your traffic actually inspected. The other thing too is that your target groups, again, will have some form of firewall, IDP, something that inspects the packet. It will allow it to actually auto scale, grow, and shrink. So let's break this down a little bit. How does Geneve work? So you have routing that we have for your source IP interface. It's basically going to say, okay, this is where we're going to send our traffic. We're capturing it, and we're going to send it to our Gateway Load Balancer endpoint. And its default route on its local network, which has to be across a routing domain, is going to say, okay, my default is to go out to the internet. From there, we're going to actually generate our packet, and then our packet will send it down to our firewalls through that process of Geneve encapsulation and out to the firewall, or out to your end target. Now, when we look at the traffic flow, we've got our packets flowing through, they're getting encapsulated by Geneve, nothing is changing, and it goes out to the end target. The end target and the source do not understand or do not care that this is being inspected. All they know is that I sent out a packet, and the receiver receives the packet and they send it back, which is what we call bump in the wire. Now, you will get a copy of this deck, as I mentioned, and I broke out, for some of you who really want to get into the weeds about Geneve, what that header looks like, but we're not going to spend too much time on this right here. What we will spend some time on is that whole idea of bump in the wire. Now, some of you may have had firewalls sitting behind a network load balancer, and the network load balancer operates at layer 4, understands TCP and UDP, and is very, very quick. But the thing is once it sends traffic, it'll actually not send it directly to its default gateway, it'll send it to the network load balancer itself, which inserts itself as part of that inspection chain. Then the traffic will go through to your firewall, and then your firewall will send that traffic out to the internet. And this may not be the best experience because your applications now need to look at the network load balancer if this is on an application level, and your troubleshooting could be that much more complex. What we do with the gateway load balancer and with ingress and even more our routing enhancements where you can do east-west capture or north-south capture is we basically set up, as I showed before, that you're sending your traffic out. You're not setting your destination as the gateway load balancer itself. You're just sending it straight out. It gets captured, sent to the interface endpoint, and then goes ahead and goes to your final end target. So let's break down what this would look like. This is going to be a very simple application. You can go hog wild with these things. So here we have our standard ALB that we saw before, and in another VPC, which could even be in another account. It doesn't have to be owned by the same account. It could be, say, an InfoSec that owns this, or a networking group that owns this. This separate account, or this separate VPC, whatever delineation you need, will have the fleets behind it. Hopefully we're well architected and doing it across multiple AZs. And then we set up our gateway load balancer endpoints. And then within our ingress routing, we say anything that's destined for 10.1.0.11 or 10.1.1.11, capture that traffic and send it to my gateway load balancer endpoint. We're not trying to capture the traffic of the application load balancer on the external because remember that gets NATed. And so we wouldn't see it until it traverses that NAT, that IGW. And then the traffic goes ahead and flows, gets inspected by the gateway load balancer, and then gets sent, if everything is okay, to our instances. So let's break down a couple of things that make it tick. As I've mentioned before, we have our fleet, we have our source, and we have our gateway load balancer. Some of the benefits that allows you is the layer 4 load balancer capabilities with the layer 3 gateway. You still inherit all those cool things with AWS config. You still inherit that it exists within a VPC, so all of those are there, as well as the fact that the horizontal scaling that you get on your back-end targets or your firewall. So you don't have to worry about those whole state things and ENI shifting or trying to change routes. You don't lose connectivity as you scale out. Once you scale out, you just simply add more and more flows. The other thing too that's important to note is because even though this thing's a little bit different, it is very close to the network load balancer. So the deployment looks very, very similar. The only thing you have to worry about is sending your traffic to those endpoints. Now, another thing I want to note that we've released recently is the fact that we have the ability for our partners, if we have any partners out here, to go ahead and offer a service to their customers with that single paying service like you would for like the marketplace where you click on it. And they can cover everything pretty much up to the gateway load balancer endpoint and the fleet. So you as a consumer can go to a partner that offers or has this service and say, okay, I want to inspect this traffic inspected, I want to purchase it from you, and the only thing that shows up in your account is a endpoint, and you can go to their portal and configure their firewalls any way you want. So that way you don't even have to worry about setting up those AMIs or purchasing those firewall pieces. You can actually let the vendor do it for you completely in a SaaS-like manner. So let's tie all this together. There's another slide that we're coming up next that I want to spend a little bit of time on. It has a lot of moving parts. And the very first time I made this slide, someone told me it looked like the flux capacitor, if any of you are old enough to remember Back to the Future. So in the middle, we have our gateway load balancer. We have access from on-prem. Let's say it's either through DX or VPC. And we have a lot of things floating around here. We have our application load balancer. It's sitting in our front end. It is offering out to the internet its ENI endpoint, and traffic is coming in. We want that traffic to be inspected. So I'm capturing that traffic with the ingress routing rules, and I'm sending it through my transit gateway, which is in appliance mode, by the way, so that it always goes to the same endpoint that we need it to go to. You can set your transit gateway to appliance mode with the CLI, or you can set it, of course, through the API. That traffic then goes to my gateway load balancer, and my gateway load balancer says, okay, this is the traffic, everything encapsulated in red. We like it, we're going to bless it, we'll allow it to speak everywhere else. So that's our services VPC, and everything is handled there. Our firewalls are scaling nicely, we're having a good time. Now, if you also look over on our database layer, we have our network load balancer. It is fast. It has long-lived flows. If someone actually connects to their database and falls asleep because your database operator or your DBA gets a little tired and he wakes up again, it's still going to have access, right? So those long-lived flows, perfect for databases. It also offers it at TCP and UDP, so it's offering and working just fine there. We have a REST API layer. We want to interact with REST. We have a whole bunch of things with our application behind our ALB in the API layer, which is in the upper right. It will go ahead and parse out where things need to go based on the URL that they need to go to. Everything's working fine there as well. And then lastly, we're using Private Link. We go to consume something from a different service. It could be a different line of business that's actually offering something out. They could be on the same IP address, or maybe they want to keep whatever it is that they're offering under their type of control, and all they need to do is offer you that Private Link endpoint that you put your security group on that must match the listener or whatever the listener is for the application in Private Link, and you can send your traffic there as needed. Now, we've moved it as close as possible to where we're consuming it. So again, we can actually take advantage of that 10 to 40 gig flow through Private Link. And all of those things are all working in harmony in this slide with the security that they've been built on, with the security that they can consume with the integrations with other AWS services, and through your configurations. So hope this one makes sense. You will get a copy of this slide, so if you want a copy of the animations, I've had people actually ask me, how do you make all those little dots move? Not a problem, we can do that. So the last note that we want to give before we go is that not only do we want you to have a secure experience with ELBs and to be able to use all the security features that ELBs have, but we want you to also look at how those ELBs should be used if you have any type of auditing software. So you can do things like check to make sure that desync mitigation mode is on, or if you have WAF on, if your ALB is actually external. All of these things here in this slide, if you put it in slideshow, when you get the slide deck, you can click on it and it will actually take you to the API so you can use it within your workloads. Secondly, here's some more that we have because I couldn't fit them all on one page, and when I tried to put it in really tiny font, it looked really ugly. So I wanted to make sure that we could add those as well. And then finally, I wanted to say thank you for coming to this session. We appreciate you and appreciate wanting to learn more about ALB, ELB, and Gateway Load Balancer.
Thank you everyone for attending this session. It was a pleasure.
If you need to ask any questions, we'll be standing over here. We won't run away, I promise.